Hello, everyone. Am I audible? Okay, fine, guys. So I think I'm audible to every one of you. And just an update for you guys. So, yesterday we had a class, right? And recordings are already available in this section. So in the neural network section, so as you can find, you will be able to find out your class recording, right? So those who are who was not able to attend the classes, or those who is having like any kind of a concern or confusion, so they can try to go through this recording, and they will be able to cover up all those things that we have discussed in a today's class. So fine, guys. Again, we are going to talk about. I think my audio is clear, right? Okay, fine, fine. Thank you. Yeah, my audio is clear. Okay, so fine, guys. So again, like in today's class, we are going to discuss about the same thing. So it is an extension of this today's class itself, right? So in today's class, we'll try to understand that how actually a neural network works, and mathematical intuition behind this neural network, and many more things we are going to visualize in today's class. So first of all, I will try to complete my end-to-end discussion, and after that, so I will try to let me open up some of my slides. Yeah. So after that, so we will try to understand that how this things actually works, right? So with the help of these graphs and all those things, right? So that these things will be very much clear in front of all of you. So fine, guys, let's try to start these things. Yeah. Okay. So yesterday we were talking about a neural network, and we have seen that neural network is nothing but it always try to find out pattern, or it always try to find out some kind of a relation. So this is the roles and responsibility of a neural network, and we were trying to correlate artificial neural network with respect to a human intelligence or a human neural network, I can say. So let's talk about again a same thing, and let's try to understand that how this entire flow works at any point of a time. So I think my wide screen is visible to all of you. Okay, so here we were talking about a neural network, and we have seen that neural network is nothing but, so you try to send some kind of a data inside a neural network. So it can be a text data, it can be a image data, it can be a audio data, or it can be any kind of a structured data we try to send. And then so what it does is, so it will try to find some kind of a relation. So now yesterday we were talking about this basic of this neural network, that okay, so we are going to send a data inside a neural network. So there will be a input layer, so there will be a input layer that you will be able to find out. Now input layer is just responsible for taking a data from any of the sources. So maybe you have a data set, maybe you have a images which is available in your directory, or maybe you have a data set which is available in some of the location, right? So you will try to fetch a data in a very first place, and then you will try to send all of those data into a neural network. Now, so whenever I'm talking about a neural network, so there are specific libraries, there are a specific framework which has been used to create all of these neural networks. Now, to create all of these neural networks, so you can try to use a TensorFlow, you can try to use a PyTorch, you can try to use ONG-ONX, you can try to use a TensorFlow JS, you can try to use Thenos, you can try to use Cafe. So these are the libraries which is available in a market, by which you will be able to create this kind of a structure, by which you will be able to create your own neural network. And it's very much easy. It's not at all a big deal if you are trying to use a Keras with TensorFlow, or if you are trying to create a neural network into a PyTorch. So if you have seen, if you have looked into your syllabus, so we have mentioned three framework over here. So we have mentioned TensorFlow, and we have mentioned Keras, and we have mentioned PyTorch. Now, so in general in my classes, so I used to talk about TensorFlow 1.x, as well as I used to talk about TensorFlow 2.x, because in many companies, in many organizations, whenever you will join, so people who are working into this neural network since last 2 year, or maybe 3 year, or maybe a 5 year, so it could possible that they might be using a TensorFlow 1.x version. And in a recent development, right? So whenever you will join in an organization, and suppose if you have to contribute, so it could possible that you will contribute in an old project, or maybe you will have to contribute in a a new project. So for sure, in a new project, so you are going to use TensorFlow 2.x, or you are going to use PyTorch. So like nowadays, a TensorFlow.x and PyTorch is being used widely across the industry. Now, on top of that, so you will be able to find out a wrapper. So wrapper means like some kind of a classes, some kind of a object you will be able to find out, which will try to give you a flexibility to write maybe 100 line of a code into 2 to 3 lines, right? And that framework is a Keras. So Keras, you will be able to find out Keras is going to make your life very much easy in terms of implementation. And coding wise, like I said, it's nothing. Every one of you will be able to write a code if you are able to understand a basic of neural network, as simple as that. Okay. And even with the help of Python, I'm going to show you that just with the help of Python, without using any kind of a framework, you will be able to create some basic neural network which will be able to understand your relations between a data. So for sure, I'll make sure that you all will be able to go through those things. Now here, coming back to our topic, right? So here in yesterday's class, I was talking about a neural network, and I said that neural network is going to take an input first of all. So there will be a perceptron. Perceptron means artificial neurons. Artificial neurons are called as perceptron. So there will be a perceptron which will try to take a data. That is fine. Now it will try to send all of those data to the next layer. So next layer is called as a hidden layer, right? So this layer is called as a hidden layer, I would say. So it will try to send a data to the hidden layer. So let's suppose if I have a 4 input neurons, right? So all of these 4 input neuron will try to send a data to each and every unit which is available in a next layer. So fine, it is going to send all of those data, right? So in this way, so every perceptron which is available in a hidden layer will be able to receive 4 inputs, right? 4 input it will be able to receive. Now here, as I told you in yesterday's class, so we used to implement a function called as activation function. So here we try to pass our data through a activation function. So hidden layer is just a name of the layer, right? And there could be a n number of hidden layer that you can create, and plus in a single hidden layer, so you can try to take, or you can try to keep as many number of perceptron as you want. But again, whenever we try to design an architecture, whenever we try to design efficient architecture, so we always make sure that depends upon the experiment, we always try to take a number of the units or number of the perceptron in any of those layers, which you will understand for sure with experiments and with many case studies and use cases. So here you will be able to find out activation function. Now, so there are many different kind of activation function which is available, like a sigmoid function, hypertangent function, a ReLU function, a leaky ReLU function, p-ReLU function, e-ReLU function, Swiss function. So there are many more functions which is available as an activation function. Now, what is a roles and responsibility of an activation function? So roles and responsibility of an activation function is to, first of all, normalize a data. So we'll talk about what is a meaning of a data normalization. So roles and responsibility of an activation function is to normalize a data in a very first place, plus try to find out a non-linearity in between the data. It could possible that there can be a linear relationship between a data, and it could possible that there could be a non-linear relationship between a data. So mostly if I'll talk about the images, if I'll talk about a speech or sound, so for sure, as we have discussed, right? So for sure, you will not be able to write any kind of a equation, any specific equation you will not be able to write, which will be able to represent our data, right? And this is where this neural network comes into a picture. So it will try to work on behalf of you, and then it will try to find out all those non-linear relation. Now, when I say linear or a non-linear relation, it simply means, if I'll talk about a linear relation, right? So y is equal to mx, right? If I'm trying to write something like that, it means what? So my y is directly proportional to x, right? So this is, maybe I can say that this is a linear relation, right? But at any point of a time, let's suppose if I'm trying to write a function, so y is equal to mx cube plus m0 x cube m1 x to the power 4 and m2 x to the power 2, something like that, right? If I wanted to write this kind of maybe my data is like having this kind of a relation, so for sure I will not be able to predefine this kind of equation. So it's a roles and responsibility of my neural network to find this kind of a relation and to train my data set. And this is what it is going to perform, and this is what it is going to do. So here, this kind of a relationship is called as a non-linear relations, right? It's not linear at all, right? It's a multinomial equation, you can say. And I'm not sure actually that what kind of a relations my data is having. So I'm just leaving up to my neural network, and that's the reason, right? To help my neural network to find out this non-linear relation. So we try to give activation function, so that it will be able to non-linearize, plus it will try to normalize my data set at any point of a time, and then I will try to get some kind of a output. So I will try to get some kind of a output from every layer. So for sure it will try to it will try to pass all of my data set into this one, and then I will be able to get some kind of a output over here. And it could possible that I can try to put maybe another hidden layer over here, right? Possible. So it could possible that I will try to implement maybe another hidden layer over here. Again, number of the perceptron into a next hidden layer. So hidden layer 1, hidden layer 2. So maybe I can try to create like a 10, 20, 50, any kind of any number of the hidden layers, depends upon me. But yeah, going forward, you will be able to understand that no, we don't do that. So we always try to design a specific architecture for a specific purposes. There is no limitation that you will be able to find out, but still we always try to design a particular specific architecture. Okay, we'll learn those things. So here it will try to pass a data to the next unit, similar in a similar way. So now this neurons or this perceptron, hidden layer perceptron, will work as, so whatever output it is going to give you, so that will be the input for the next layer. So find this input will get inside all of these neurons one by one, one by one, one by one, right? And finally, again, it is going to give you some kind of output. So finally, it could possible that you will try to send this data to the next layer, right? And I can try to mark that layer as a output layer, right? So output layer. So here we have input layer, hidden layer, and output layer. As simple as that. So output layer will try to give you a final prediction. I'm just trying to represent those prediction with respect to y hat. So y hat means the prediction, or like the output which I'm able to get from the neural network. As simple as that. So in a very first place, right? Now you must be wondering that what it will do with this output, right? It's a numerical output which it will try to give you. And suppose it has given you some kind of output. Now, for sure, when you have passed your data for the very first time and you have received an output, so your output given by a neural network will not match with an output that you were expecting, the output which is already available inside your data set. So I think we have taken like a some table we have considered in yesterday's class, and then in a table, so we were having some kind of a data, we were having y values, right? So it will try to give you y hat, means it will try to give you a predicted value, and then you will try to match with what? You will try to match with your expected one. So y is nothing but it's a expected one at the time of a training. So now for sure there will be a differences you will be able to find out, and that difference is called as a loss. So loss means like a difference between expected one and the predicted one. You will be able to receive a loss. Now what you will do, and why you have received a loss? You have received a loss because whatever weights that you have considered in between, right? Whatever weights you have considered in between, so maybe your weights are not able to give you a similar kind of a relations which is available inside my data, because what you have done, you have basically taken a random weights in a very first place, right? So it is going to give you a loss. Now you are supposed to minimize this loss, right? Anyhow, if you are able to reduce a difference between expected one and the predicted one, so expected one and the predicted one, so for sure you will be able to say that fine, my network is trying to learn something, or my network is able to like find some kind of a relation. So the whole objective and idea is to minimize a loss. Now this approach, when we are trying to pass a data from our input layer towards output layer, right? So whenever we are trying to pass a data, right, from here to here, whenever we are passing a data from here to here, that is called as a feed forward network or feed forward connection. So we are trying to feed a data into a forward network. Now in a feed forward network or in a forward direction, right, it will never try to learn anything. So it will simply just try to pass a data. It will try to do a multiplication with the weights, and it will try to give, or it will try to send a data to the activation function. Activation function will give you some output. Again, you will try to give that output as an input to the next layer, right? And finally, you will be able to get Y hat or Y prediction, right? Now, so in this one, in this forward connection, so it will never try to learn anything. Learning means what? Learning simply means that finding out the pattern, right? And how it will be able to find out the pattern? So somehow, hypothetically, right? Hypothetically, if I'm able to find out a weight which can define the relationship of the data, right? Because anyhow, you are trying to multiply your data or your input on every layer with respect to a weight. So anyhow, if I'm able to find out an absolute weight which can represent my data, so I can say that, okay, fine. So I'm able to find out, or I'm able to get the relations, right? So I will be able to get the relation. This is what I can say, right? This is what I can say easily. So in a forward connection, it will never try to learn anything, or it will never try to change your weights. It will simply try to multiply. Now it will try to give you a loss. Loss is nothing but it's a difference. It's a difference between Y and a Y hat at any point of a time, expected and the predicted one. Now, once you will be able to get a loss, then what it will do? So then it will try to do a backward propagation. So this is called as a backward propagation, right? And in a backward propagation, it will try to do what? It will start changing the weight. So for sure, we need some mechanism. We need some mechanism to change this particular weight. So that particular mechanism is called as a optimization. Optimization. So again, it's a mathematical function, I would say, right? So based on the loss. So again, it's not like I will keep on changing my weight randomly. No, not at all. So whenever I'm trying to change a weight which is available inside my neural network, right? So those changes should happen based on the losses, I would say. So at any point of a time, so we are supposed to find out a new weight. So let's suppose at every layer we have a weight. So the new weight, so weight new will be nothing but, so weight old, so the old weight that you have taken minus eta of dE by dW. So this is how it is going to change a weight, and this approach is called as a learning. So whenever someone is asking you that what is your understanding about a learning, right? So learning is nothing but based on the loss, when you will keep on changing a weights, right, inside your neural network. So that particular part is called as a learning. So at that point of a time, it will try to adjust itself. It will try to adjust a weight according to the data, so that the difference between these Y and Y hat will be minimum. And again, there are many different kind of a loss function which is available. So don't think that it's a Y minus Y hat. You are going to see many different kind of a loss function, and even you are going to utilize many different kind of a activation function. So here you will be able to find out that our new weight, right? Our new weight, again, when I'm saying weight, right? So weight is available here, here, here. Weight is available in all the lines that you are able to see inside this neural network. So all of these things are representing what? All of these things are representing a weight, I would say. So W1, W2, W3, and so on. So we try to define our weights all the time. And in a very first place, we don't have any idea that what kind of a weight is going to like good for me, basically, or good for my data. So initially it will always try to take a weight as a random number, as simple as that. So there is a function which is available inside a NumPy, inside a TensorFlow, inside a PyTorch, by which you will be able to generate a random number. So in a very beginning, weight will be nothing but it will be a random number at any point of a time, right? So in a backward propagation, we will start changing our weights. We will start changing our weights, and we will keep on changing these things unless and until we are not able to get an optimal loss. right? Unless and until we are not able to change all the weights, and unless and until we are not going to reduce the losses, we will keep on like sending a data, and we will keep on doing this backward propagation. So in a forward propagation, again, so let's suppose in a very first time, so you have sent some data, right? You got some kind of a loss. Now in a backward propagation, so you are trying to change the weight. So you have changed this weight, you have changed this weight, you have changed this weight, and then you will change this weight, then you will change this weight, then you will change this weight, so on this layer, and then you will try to change a weight on this layer. That's the reason, so it's called as a backward propagation. So it will start from this layer first of all, then it will go to this layer, then it will go to this particular layer. So layer by layer, from a backward direction towards a forward direction. So it will keep on changing the weight. And again, as you can see, the equation which I have written over here, so every time whenever it is trying to find out, let's suppose this weight, right? So this weight, the new value of this weight will be nothing but a older value of weight, because for sure you have to depend upon your older weight. So whatever changes that you are going to do, so for sure it should be proportional to the previous weights that you have. So you are going to take a older weight. So let's suppose if I'm talking about this one, right, this weight, so old weight minus, I'm trying to like give one notation over here. This is called as eta, right? Eta. Now it's called as a learning rate, right? It's called as a learning rate. So our new weight is nothing but old weight minus eta, which is a learning rate. I'll talk about what is the meaning of learning rate in just couple of minutes. I'm going to talk about that. So it will try to give you a new weight, and new weight is nothing but old weight minus eta into dE by dW. Now what is the meaning of this, right? So here we are able to find out loss. We know that whenever we are supposed to make any kind of a changes, right? Whenever we are supposed to make any kind of a changes, right? It always depends upon the older weight. Fine. So we have included that factor. Now, so older weight minus, we are trying to take eta into dE by dW. So dE by dW is nothing but rate of change of error with respect to weight. Simple. So let's suppose rate of change of error with respect to old weight, which I'm trying to consider. Now, what is the meaning of this error? So error is nothing but it's a loss, which I'm talking about. So this is the error which I have received, right? So error is nothing but a difference between y and y hat at any point of a time. So rate of change of error with respect to w. So with respect to a weights, we are supposed to find out rate of change of error at any point of a time. And then if I'm able to find out that particular factor, it's just a differential. So just a very simple differential equation, right, that we have over here. And I think we all know that suppose we have like a y, right? Y is equal to x square. So now if I'll try to do like a dy by dx, rate of change of y with respect to x, this is how we can pronounce, right? Rate of change of y with respect to x is nothing but 2x. We all know that, right? So like a y is equal to x to the power n. So dy by dx at any point of a time is nothing but n into x to the power n minus 1. This is how we try to calculate a differentiation of a simple, I would say, like a y and x, if we have this kind of a relation. So again, our weight is having relationship with respect to an error, and we know that, right? Why we are able to receive the error? Because our weight was not aligned properly. I was not able to find out an exact and accurate weight, and that's the reason. So I'm able to get a error. So at any point of a time, so I'm supposed to change what? I'm supposed to change a weight. My input is not going to change. My data set, because input is what? Input is a data, right? So I'm not going to change my data at all, right? So whatever data I'm going to provide, it is supposed to find out a relationship between those data set. Simple, right? What I have to do? So what I can control over here, I can control a weight in this particular place. So changing this particular weight is called as a learning. So learning always happens in a backward direction or in a backward propagation. In a feed forward connection, so it is not going to change even a single weight. It will just try to do a calculation, and then it will finally give you an output. So you will change the weight. Again, you will pass the data. Again, you will be able to get some kind of a loss, some kind of a difference between y and y hat. Again, you will do the same thing. right? So you will keep on changing the weight each and every time. You will keep on updating the weight each and every time, unless and until loss is not going to be a optimal one. So once you will be able to find out an optimal loss, then you can say that, okay, fine, so I'm done with this like a relationship, I'm done with this particular learning, or I'm able to find out some kind of a relations in between a data. Now I'm good with that. Now, so I can try to utilize this particular network that I have created, right, for my prediction. So at the time of prediction, so this is called as a training, right? At the time of prediction, what you will do, so at the time of prediction, so you will just pass the data and your weight is already trained on top of that data, right? So it will try to give you some output. So again, if your data set is having a relationship between the previous one, the data set that you have used, it's not like you will be using some other data at the time of training and a different data. So suppose if you're trying to build some use cases for maybe healthcare analytics, right? So it's not like you will try to like give a healthcare analytics data at the time of training, and then you will try to like test these things with the retail data set. Not like that, right? So for sure, even at the time of testing, so you are supposed to use a same data, because this network has been trained for that particular specific use cases, right? Like our human body, right? So different body part, different neurons which is available in our body, so is responsible for doing a different task. So like I can't say that, okay, fine, so by by using my eyes, so I will be able to listen something, or by using my ear I will be able to see something. Because my the neurons which is available in my ear, so that can't see, that is responsible for listening, that is responsible for capturing some kind of audio signal. My eyes is nothing but, so it is responsible for capturing some of the light waves, light electromagnetic waves, I can say. So this is again same thing applies over here. So this is a specific neural network that you will end up designing for a specific kind of a data set. Simple. Now coming to this equation, because this equation is a very much important equation, and even in your slide, so we have given you a derivation of this equation which we are going to talk about. So like probably by next week, so we are going to discuss, we are going to talk about, because by that time you will be comfortable with some part of differential. I'll talk about some part of differential as well, differential like a calculus, just for the revision, just so that you will be able to recall all those like a childhood memories, and then you will be like able to learn in a better way. Okay, so here my whole idea and my whole objective is to find out a weight, as simple as that. Now here you must be able to see that I'm trying to use old weight minus. So again, this depends upon the direction. So again, it could possible that this is going to give you minus. So in this case, this is going to be a positive one, right? But in general, whenever we try to define the equation, so we try to take a minus, again based on the direction of this one. So this can change for sure. So plus or minus always. Now here you will be able to find out that, okay, so we have used a factor called as eta. Now here what we are trying to do, so let's try to understand this d by dw. So here what we are trying to do exactly, so here we are trying to find out error, rate of change of error with respect to w. That is fine, but let's suppose if I'm able to get rate of change of error is equal to 5. I'm just hypothetically, I'm just taking some number, right? So rate of change of error with respect to w, let's suppose if I'm able to find out as a 5. So am I supposed to reduce my weight by 5 units? No. So if I'll try to rewrite, let's suppose eta, right? So eta value is equal to, let's suppose 1 if I have taken. So eta is equal to 1 if I have taken. So in that case, w new weight is nothing but old weight minus, right? Eta is equal to 1. So de by dw, right? So let's suppose this factor is equal to 5. So am I supposed to reduce my weight by 5 units? I'm not talking about like any numbers, I'm just talking about unit, right? So like I'm not taking any kind of a scale over here, I'm just taking a unit over here. Okay, just like try to focus. So here you will be able to find out that, okay, I'm not supposed to like reduce this particular error directly to this weight, because what happens is, let me give you one scenario, right? So let's suppose so suppose you are trying to learn something, you're trying to learn a neural network. As of now, we all are trying to learn as of now a basic of neural network, right? Now you must be very much confused with respect to every layer. that I have designed as of now. Maybe you have some confusion with the input layer. Maybe you are wondering that how we are going to take a weight. Maybe you are wondering that how we are going to take activation function, which activation function, users of activation function, calculations for sure, because I have not written any kind of a mathematical equation so far, so forth for this like a internal data calculation, right? Which we'll discuss in a later stage, right? So for sure, you will be confused. Now, if I'll ask you to solve some problem in a neural network, so maybe you will end up producing a huge amount of a error. A huge amount of error means, so I will give you some problem statement, but you will end up delivering some other solution, some different solution, which is not even related to this particular one, right? So in that case, what is the error? So I can say that in that case, error is huge, means you have not learned properly, right? And in that case, you will try to produce a huge amount of an error. So am I supposed to reduce this entire error in a single shot? Or so what is the meaning of that? Let's try to understand with respect to a human being, right? So when I'm saying that am I supposed to reduce an error in a single shot, it means what means what? So it means it means what basically? So it means what, am I supposed to learn everything into a single shot? Will I be able to learn everything into a single shot, right? If I'll start writing an equation like an input, then like a calculation in between the weights, and then hidden layer activation function calculation, and then final output calculation. If I'll start writing all the mathematics, which we are going to discuss for sure in this particular slide. So let me share this slide with all of you. So if I'll start talking about this calculation, directly with you, right? If I'll start talking about this calculation directly, right? Will you be able to understand? No. To understand this particular calculation, right? To understand this particular mathematics that you are able to see, although this mathematics is very easy, you will be able to find out for sure, right? You will be able to find out these mathematics are very easy, but in a very first instance, in a very first hour, if I'll start teaching you all those things, you will again not be able to learn properly, right? Then what is a proper way of learning? A proper way of learning is to go slow, right? Slowly try to learn one thing, then another thing, then on top of that, so keep on adding a new things, right? This is how we all human beings learn, right? So basically what happens is, and again, so if in this way, slowly, if you are able to train yourself, slowly, gradually, if you will start connecting each and everything, so for sure you will be able to learn something into a better way. A same hypothesis is been applied even over here, right? Same hypothesis has been applied over here. So whenever you will be able to introduce an error, means whenever you will be able to find out a huge difference between y and y hat, so you are not supposed to reduce all of those error in a single shot. It's not like if you're not able to do something, then you will try to complete everything in a single shot, right? Starting from the very beginning till last. No. In a single day, I will be able to teach you all the 1020 activation functions and a loss function and a optimizer. So Adam optimizer, or like ADA delta, ADA grade, or Newton's functions, I will be able to teach you. But will you be able to understand? No. So in that case, your learning curve will not be completed, right? So we are supposed to learn slowly and gradually, and we should connect each and everything one after another. And same thesis, a same hypothesis, people have applied even over here, and people said that no, whenever you are going to get an error, right? So don't try to reduce the entire error. Don't try to reduce an entire error in a single shot, right? In a single update. So don't try to reduce the entire error. Just do one thing. Try to learn slowly. Just do one thing. Try to update your weight slowly and gradually. Then you will be able to learn in a proper way. Because when you try to learn everything into a single shot as a human being, right? So again, it creates a huge amount of a confusion. Huge amount of confusion in terms of I will try to say something, you will try to understand something, and then you will try to perform those operations in some other way, right? So again, it will try to create a chaos. And keeping these things in mind, people said that no, whenever my perceptron or whenever my neural network is trying to learn something, we are not going to follow a similar kind of approach. What we are going to do, we are going to learn slowly and gradually. And they have suggested that no, whenever you are able to get an error, you're not supposed to reduce, or you're not supposed to reduce this entire error with respect to a weight at any point of a time directly. What do you have to do? So you have to introduce a something called as eta. Now eta value can be 0.01. Now let's suppose my error is equal to 5, eta value is equal to 0.01. So if I'll try to multiply 0.01 into 5, so 0.05 I will be able to get. So now error was 5, but how much unit we are reducing from a weight? So we are trying to reduce 0.05 hypothetically. Let's try to understand. So they have given an hypothesis that you are not supposed to learn immediately. You are supposed to reduce. Learning means what? Reducing an error, right? Even in case of a human being, so you are trying to learn something. It means what? So layer by layer, you are trying to reduce your confusion. You will ask many doubts, and then again you will try to clarify it. Again, like a next doubt clean session, you will get some other kind of a doubts, right? Again, you will try to clarify it. And then in this way, you will try to learn. Means what? You are trying to reduce an error in your whatever topics that you are trying to understand. So you are trying to reduce an error slowly and gradually. And same hypothesis people have given over here, that no, I will not try to update my weight directly, which is proportional to or with respect to an error. So what I will do is I will try to introduce a learning rate. This is called as a learning rate. A rate by which you will try to update your weights, I would say, right? A learning rate. How it happens in terms of mathematical operations, what is a gradient descent, and what is the meaning of this like a graph, and many more things we will try to understand. So this gradient descent, how it is going to achieve a local minima, many more things comes into a picture. Just wait for some time. But here, what I'm trying to convince, what I'm trying to explain over here is that we always try to learn gradually and slowly. In this way, I will be a better learner. I will be able to clarify each and everything, right? Same thing happens with the neural network that we used to create artificial neural network, ANN, right? Artificial neural network, whenever you are going to create, we are talking about ANN as of now, right? So basically you will be able to create a better neural network for a particular specific task with respect to a specific data set. If you will try to update yourself, update your weight in a slowly. But again, when I say in a like a slowly, or maybe like when I'm saying like slowly and gradually, so again, if I'll try to take this value of eta, like learning rate is 0.000001, and then if I'm trying to multiply error, so in this case you will end up getting 0.0000 and 5. So again, this is too slow. I can say if I'm trying to take learning rate is equal to this one, so means eta value is equal to this much, right? So in this case, it will be too slow, right? So it means what? So as a human being, if you will start learning something and you will say that, okay, fine, so today I will learn like a input layer, then tomorrow one hidden layer, then day after tomorrow another hidden layer, or day after tomorrow one activation function I will try to learn, and then I will try to like learn how this calculation happens, then I will try to learn calculus, then I will try to learn weight update and many more things, but in a slowest possible way, right? Maybe you are taking one week of time to learn just a small things. So maybe it will take an year for you to get acquainted with this entire neural network architecture, and you will not be able to learn, right? You will not be able to learn properly. Maybe you will start learning something and then you will start forgetting something else, right? So same thing happens even over here, I would say. So whatever applies on a human being, so same kind of a things gets applied even over here, and you will become a slow learner, right? So we all like so we all are a human being, right? And we have seen that some of us are a fast learner, some of us are a slow learner. What is the difference between them? So between slow learner and fast learner. So our brain is trained in such a way that some of us try to acquire or try to understand or try to find out a relations very quickly, right? Or some of us takes time, and it happens with respect to each and everyone, right? So everyone's neurons or nervous system is not same. Everyone's neural network is different. They have a different kind of a learning rate. And that's the reason so we used to say, okay, so some of you are slow learners, some of you are a very fast learner, right? So same thing applies over here. So you are not supposed to be too slow. You're not supposed to be too fast. It should be like a in a steady condition, so that you will be able to find out all kind of a relationship between a data set at any point of a time. So again, this learning rate is a hypermeter. Hypermeter means what? So hypermeter means you will have to experiment, and then you will have to find out that which learning rate is a most suitable learning rate for this particular example. So sometime we used to take 0.01, 0.003, 0.02, right? So again, in many different kind of a neural network architecture, you will be able to find out that people have taken a different kind of a neural network. They used to experiment that with which learning rate, right? With which learning rate I'm able to reduce our losses, because a whole idea over here is to reduce this particular loss, right? This is the idea. My whole objective is to reduce this difference between prediction and the expectation that I have, right? So it's just experimental values. So hypermeter, so whenever I'm going to take a name hypermeter, that whenever I'm going to say that, okay fine, so this one is a hypermeter, it simply means that with experiments you will be able to find out a values. But again you will be able to see some of the optimizer, like a Adam optimizer, ADA delta, ADA grade optimizer. So these are the optimizers where you will be able to find out that it try to changes a learning rate with respect to each and every epoch. So we'll try to discuss, we'll try to talk about that. But as of now, as a beginner, right? As a beginner, because this is just your first and second class, right? So as a beginner, just try to like keep these things in a mind, that learning rate is a hypermeter, and we are supposed to do an experiment, and then based on those experiments, so we are supposed to pick and choose a learning rate. In a later stage, I will change my definition. When I'll talk about Adam, when I will talk about ADA delta, ADA grade, I'll change my definition for sure with respect to a learning rate. But as of now, this is the like things that you are supposed to understand. As simple as that. Okay, so the whole objective is to do what? Is to change my weights. As simple as that. Now, let's try to reinvent a wheel again. So I was trying to talk about a neural network, right? I was saying that, okay, fine. So I will try to send a data. Many of you will get confused that, okay, so suppose we have many data set, and then why we are taking just a 4 neurons over here, or 3 neurons, or like 100 neurons, how we are going to decide all of these factors. I will come to those points. Okay, so this is the input. Let's suppose I'm going to pass input as x1, x2, x3 and x4 as an input I'm trying to pass. Now let's suppose I have a neurons over here. Let's suppose I have a neurons over here, and this neuron is trying to get a input from all of this like input neurons. So here what we can do is, so in a very beginning, I can try to define the weight W1, W2, W3, W4, or in this way. So what we can do is, so we can try to define in this way. So let's try to use a proper naming convention. So this is, let's suppose, a layer 1, right? And this is, let's suppose, a layer 2. So input layer 1, I'm trying to represent, right? So just a notation from my side, that's it, nothing else. So it will try to give you inputs, it will try to receive the input. So x1 input it has received, right? And then like okay, so we have like a w1, we have a w2, we have a w3, we have a w4. I'm just trying to consider only one neuron, forget about all these two, so that it will be easier for us to do a calculation, right? So it will try to take it, there will be a weight, and these weights are basically what? A random weights. Initially I won't be having any kind of idea. So what input will get inside this particular neurons, which is available in a second layer or L2 layer, which is called as hidden layer. Okay, so what is the input which will get inside this one? So the input which will get inside this one is nothing but x1 w1, right? X1 multiplied with w1. So x1 w1, right, plus x2 w2, x2 w2 plus x3 w3 plus x4 w4. So this is an input that it will try to take. So this is the input which will get inside this particular neurons, which is available in a very first hidden layers at any point of a time. So again, if you will try to focus on this unit, right, so you will be able to find out that I'm talking about a relations called as y is equal to mx, and this is a linear relations, or this is basically representing a linear data set, or you can say that this is representing basically a line. So suppose if I have to like draw a line, so if I have to like generally whenever we write an equation of the line, so line equation of the line is what? Y is equal to mx plus c. It means what? So in a hyperplane, so if we are trying to draw the line, so this is the line, right? M is nothing but a theta value, slope of this line, and c is nothing but this intercept value. So value of y when x is equal to 0, right? So this value is called as this is called as an intercept, and that is basically it's nothing but it's a c, right? So here you will be able to find out, let's suppose c is equal to 0, so y is equal to mx, right? Y is equal to mx. So here you will be able to find out that I'm trying to pass what? A linear data set, right? Doesn't matter what kind of a data that we have, but at any point of a time, I'm trying to pass what? I'm just trying to pass a linear data set inside this one. But it could possible that this x2, right? It could possible that this x2 is not contributing much in a relations, right? This x2 is not contributing much in a relation. For example, right? Let's suppose I'm trying to write this equation. So m1 x1, again same like a x1 w1 in similar way, similar fashion. So m2 x2 plus m3 x3. Let's suppose this is the equation which I have written. As you can see, it is trying to take three input, x1, x2 and x3. Let's suppose, so I'm trying to give you a data where, so y is nothing but height, right? Y is nothing but height, x1 is nothing but weight, right? X2 is nothing but, you can say, age, and x3 is nothing but x3 is nothing but, you can say, your like employee ID. Okay, so here you can clearly suppose this is the kind of a data which I'm trying to pass as a x1, x2 and x3, right? As a x1, x2 and x3. So I'm trying to pass weight, age and employee ID, and then as a y, so I'm supposed to do a prediction for a height, right? I'm supposed to do a prediction for a height. So clearly you will be able to observe over here that weight is having some relationship with height, true. Age is having some relationship with height, true. As of now, we know that. We know this fact. We just, that's the reason. So I'm trying to talk about some known entities over here, right? So yes, you can say that weight is having some relationship with height, age is having some relationship with height. But what about employee ID? Do we have some relationship of employee ID with respect to your height? No, not at all, right? So whenever you're trying to pass your data, so it could possible that some of them is going to show a relation, some of them are not going to show a relation, some of them will try to show some different kind of a partial relation, or I don't know basically. So what is the contribution on this height for this entire data, right? I don't know basically that what is the contribution of this particular like a data set with respect to height, right? And this is what my network is supposed to find out. If my network is supposed to find out these things, it simply means that it is supposed to find out what? M1, M2 and M3. This is what I'm trying to represent over here by weight, right? So M1, M2 and M3 is nothing but it is trying to represent a relationship between my X and Y, my input and my output. As simple as that. So somehow if I'm able to find out a value of M1, M2, M3, it could possible that I will end up getting M3 is equal to 0 or maybe close to 0, right? Close to 0. Possible, right? In this, this means what? So if I'm saying that, okay, fine, so I will end up getting a value of M3 close to 0, it means simply that we are trying to neutralize. We are trying to neutralize or we are trying to deactivate this particular relation. We are not going to consider this relation, right? And how we are going to find out this like a W1, W2, W3, W4? In a backward propagation, we have seen the equation W nu is equal to W old minus eta into rate of change of error with respect to W, right? So it's not my responsibility to find out that which one is going to contribute or which one is not going to contribute. It's a roles and responsibility of a neural network. In a backward propagation, that's the reason. So it is supposed to update what? It is supposed to update a weight. But in a very beginning, when I will try to start my task, right? When I'll start giving a data input, at that point of time, I don't have any idea that what is a weight that we are supposed to consider. What is that's the reason. So I used to say that, okay, fine. So we are going to give a random weights, right? Just random number, right? Just a random number. In a backward propagation, automatically we will try to change those numbers. Depends upon the relations. Depends upon the findings, it will try to change all of those things. If there is a relation, yes, it will be able to find out. But initially, you are supposed to pass what? You are supposed to pass. You are passing what? You are passing this linear data set. You are trying to pass what? You are trying to pass this entire linear data set inside hidden unit. Now, what happens inside the hidden unit? So inside the hidden unit, like I said, so there will be an activation function. Activation function that you will be able to get. Now, activation function wise, there are many different kind of activation function that you will be able to find out at any point of a time. There are many more activation functions that you will be able to find out at any point of a time. So there are some of the popular, well-known function that you will be able to see over here. So here we try to pass our data into where? Into an activation function. So let's talk about one very simple activation function over here. So let's suppose we are trying to say these things as a Z, right? So I'm trying to represent this entire equation as a Z because Z is something that we are trying to pass into a hidden unit. Now here inside a hidden unit, let's suppose I have applied one function, right? Now, so let's suppose I have applied f of z, and f of z is nothing but 1 plus 1 plus e to the power minus of z. Let's suppose I have applied this function, right? Now, what is the meaning of this function? Why we have applied this function? What is the meaning of activation function? What it tried to activate? What it tried to deactivate? What is the normalization, right? How it achieve it? What is the need of that? So there are many more questions that you will be able to get, right? Let's try to find out those answers over here. So we are trying to pass this entire linear data set into an hidden unit, right? Now, so here in this particular place, what will happen? So we are trying to apply an activation function in this particular place. So here it will try to send this data to this activation function. Now, so if I'll talk about this specific activation function, so this activation function is called as a sigmoid activation function. And if I'll try to plot a graph for this sigmoid activation function, so you will be able to find out this is a graph that you will be able, I'm not good with the pictures actually, but here I'll just try to draw it. So this is a kind of a graph that you will be able to find out. So value will always be in between 0 to 1 for minus infinity to plus infinity. So as you can see over here that this is the x-axis, this is a y-axis. So this is the kind of activation function where doesn't matter what value of a x that you are going to pass. Your output will always be in between 0 to 1 at any point of a time. So I can pass any kind of an input. There is no problem with that, right? But so I can pass any kind of an input over here, right? But if I'm going to send some data, let's suppose over here inside the activation function, so at any point of a time, it is going to give me output in between just 0 to 1, as simple as that. So for like all the values in between minus infinity to plus infinity, it is going to give me a data value in between 0 to 1. Again, like a sigmoid function, there are many more activation functions which is available. Like I said, hypertangent, leaky ReLU, eReLU, pReLU, right? Swiss function. So there are many more activation function which is possible, and we are going to talk about almost every kind of activation function which people have discovered till this year, right? In our classes, one by one, we will try to understand the mathematical implementation. But before that, let's try to understand why we are using activation function here, right? So whatever data input that you will be able to get, right? So multiplicative summation of all the data, or I can write Z is nothing but summation of xi wi, where I is equal to 1 till n. right? So this is a data that we are going to pass inside our activation function. So if I'll talk about this situation, so if I'll try to write this activation function, so f of z is nothing but 1 by 1 plus e to the power minus of z. Now our z is nothing but over here, so 1 plus e to the power minus of x1 w1 plus x2 w2 x3 w3 x4 w4. This is the z, this is the z that we have, right? This is the z that we have over here. This is the z that we have taken. This is the z that we have taken. So fine, we are going to pass this data over here. It is going to give me a value ranging in between 0 to 1. As simple as that. So whatever input I'm trying to pass over here, this is the combined input, a linear input I'm trying to provide over here. It is trying to do what? It is trying to give you some value in between 0 to 1 again. So for this combination, you will try to pass this data, right? And again, so it is going to give you some values. Again, it is going to give you some values. And here again, weight will be different, right? Weight will be different. Again, you will try to do same thing with this one. And here also you are going to apply an activation function. So every data, every linear data that you are going to send, that you are going to give inside the hidden unit. So yes, it is going to apply an activation function throughout the layer. In one single layer, you are supposed to use one kind of activation function. If we have multiple hidden layers, I can use a different kind of activation function into a different layers. You will get to know which one is a more suitable activation function, in which case you are supposed to use what. Everything you will be able to understand. It will take some time. So here we are trying to pass this entire input data into an activation function. Like I said, this activation function, specifically this activation function, sigmoid activation function, if I'll talk about, it always gives me output in between 0 to 1. So it means what I have, let's suppose the cumulative summation, let's suppose x is equal to 4, x2 is equal to 5, x3 is equal to 8, and x4 is equal to, let's suppose like 0.2. W1 is equal to random value which I have taken, right? Random value which I have taken, W1, right? So W1 is equal to 0.01, W2 is equal to 0.02, W3 is equal to 0.001, and W4 is equal to 0.05. So this is the random value of weight which I have taken, right? This is the input which I had from my data set. So let's suppose if I'm trying to give like a data input over here, x1, x2, x3, x4, and y. So this is the data value. So first row, if I have given, let's suppose I'm giving just a first row data, right? x1, x2, x3, x4. If I'm trying to give over here, so and this is the weight which has been defined in this particular place. So can any one of you give me a value of z quickly? So you can ping me in the chat box, quick. Yeah, guys, quickly just try to check this one. So someone is saying that, is it always that from every perceptron input will be passed? Yes, in a very beginning, so input will be passed. In a later stage, so based on the weight, it will try to activate or deactivate. Sir, repeat the question. Try to like not to sleep in a class. So x3 is equal to 5, x3 is equal to 8, I have written. x3 is equal to 8. Quick, guys, quick. From tomorrow on, so from next class onwards, so whenever you are coming to the class, so like make sure that you have a copy and pen and calculator. Okay, maximum of you are saying that 0.158. Z is equal to 0.158 is a value that you are able to get. Okay, fine. So I don't know whether it's a correct or like whether it's a incorrect, but I will try to consider I will try to consider this output from the majority. So majority of you are saying that it's a 0.158. So this is the value of Z that you are able to get. Now just do one thing. right? Just do one thing. So try to put this Z in this equation, and now give me the value. It will be same to. Guys, quick. If value of Z is equal to 0.158, right? Then what is a value output of the sigmoid function? Just give me that. People are saying that 0.539. Okay, majority of you are saying that 0.539. So if you are going to pass, this data over here, so finally you are able to get a value 0.539. Okay, majority of you are giving value 0.539. So this is a value that you are able to get out of the first one. Means what? So it is going to give you output as 0.539, right? 0.539 is an output that it is trying to give it to you. Okay, so let me okay, so 0.539 is a value that you will be able to get out of this right now. So similarly, it will be able to get some output from here. Similarly, some output from here it will be able to get. Let's suppose if I'm creating another hidden layer unit in this particular place. So again, there will be a weight, right? So maybe a W like a 10, a W11 and W12, right? And now we know the output. So output will be the input, and then we will try to do the same kind of operations. I can try to use some different activation function in a different layer, but in a single layer, throughout the layer you are supposed to use. So suppose if I'm talking about this layer, so throughout this layer there will be only same activation function that you are supposed to use. In other layer, yes, you can try to use any other activation function that is possible. Okay, and again, so number of the input or number of the unit or the perceptron that you are going to take over here is a variable. I'll show you like a real-time representation as well in some time. So just wait for some time. Yeah, so as you can see that we are able to get any values output in between 0 to 1, right? 0 to 1. Now what is the meaning of that, right? I have given a data set is equal to 4, 5, 8 and 0.2, right? So the dispersion of my data set, if I'll talk about, so dispersion of my data set was in between 0.2 to 8, right? That was a variances which I have given over here, right? But finally, I'm able to get what? I'm able to get 0.539. Once I will try to change this weight, let's suppose in a backward propagation, we are trying to change the weight, right? So again, in a next time, so it is going to give me some other values, because anyhow, it depends upon the weight, but still it will be in between 0.01. So can I say over here, can I make a statement over here that I'm trying to normalize my data, or I'm trying to scale down, or maybe I'm trying to bring my entire input in between certain scale, I would say. So by applying this activation function, so I'm trying to bring down my input in between 0 to 1 in this particular way. Because if your data variance is very high, right, it will be very difficult for anyone to understand the pattern in between a data, right? If I'll give you some value ranging from 0 to 1000, random value, if I'll give you, it will be very difficult for you to understand, interpret, and then give me some kind of a pattern. But if I'll give you, let's suppose, a data set which is ranging in between 0 to 10, you will be able to find out relations in an easiest possible way, right? Same thing happens over here. So we are trying to perform a normalization operation, plus we are trying to do what? So we are trying to perform a non-linearization operations as well. Sigmoid is a non-linear function over here. Sigmoid is not a linear function at all. It's 1 by 1 plus e to the power minus of z that we have taken. So it's basically a non-linear function. So we are trying to pass this entire input into some non-linear function, and then we are trying to generate an output. And while doing this, so we are trying to achieve a non-linearity into a data set, I would say. So activation functions has been used for normalization, and it's been used to achieve a non-linearity in between a data, basically in a feed forward connection, I can say. So whenever you're trying to propagate a data from a very first place till a last place, so this is what happens at any point of a time. Okay, so fine, not an issue. So here I will be able to get 0.059, and what will happen is like okay, so if I have another hidden layer, it will go over there, same operations, and then finally I will be able to get an output, right? So let's suppose for this data I was expecting 0 and I have received 0.02, or let's suppose I have received 0.5 what was the value? So 539. So I have received 539, but I was expecting what? I was expecting 1. Possible, right? Or maybe I was expecting 0. I was expecting 0, I have received this much, right? So if I'll try to apply a thresholding, that if value is more than 0.5, so in this case it should be equal to 1. Thresholding if I'm going to apply. In case of a classification problem, in case of a regression problem, we can take this data directly, right? And so I was expecting something else, I have received something else over here, right? There is a difference in between. I have to reduce the differences. So this is called as a loss or error, you can say. So I will try to do what? I will try to update all of those weight. This weight, this weight, this weight, this weight, I will try to update. Now, how we are going to update? So let's suppose we are supposed to update W1. So W1 new is equal to W1 old minus learning rate eta into rate of change of error with respect to W1. I can say W1 old, I can say, right? So this is how I'm supposed to find out a new weight, and new weight depends upon what your loss or error that you have produced, right? So every weight was different. Every weight was different. It will keep on changing the weight one after another. So again, next time you will pass up next row. So next time you're going to pass, let's suppose this row, then this row, right? So you will keep on passing this different kind of a data. It will keep on tuning your weights basically, because based on the losses, so it will keep on changing your weights based on this equation, I would say. So again, the heart of this equation is this one, dE by dW. This is what we are going to derive from the very scratch by using a chain rule and differential calculus. Again, so the slide which I have shown you yesterday, right? So in that slide, so there is a very scary like a differentiation that I have mentioned, right? So this is what we are going to do in the next class. So by next class, I think you will be able to understand all of those things for sure. Yeah. So I'm supposed to change the weights. Again, I'll try to pass a new data. Again, I will try to change the weights. Again, I'll try to pass the new data. So in this way, I will end up passing the entirely new data set. And then I will end up changing the weights again in the next iteration. Again, I'll try to pass all the data. So I'll keep on passing this data. I'll keep on changing this weight one after another. And finally what will happen? So finally you will be able to get some weight in this particular place, which will try to give you y hat closer to y, and in that case I can say that my loss is minimized. Means there is not much differences, or there is no differences in between y and y hat. It means whatever weight which I have taken over here, means whatever weight which I have trained, or whatever weight which I have like changed over here, is a weight which is defining a relationship which is available inside my data, right? So as you can see, this entire graph, if you will just try to look into this entire graph, right? So this entire graph itself is trying to achieve a non-linear. Let's suppose I have like a 3 unit over here. This is the network that we have, right? So this is a very simple network, let's suppose, that we have. So I can very clearly say that this graph itself is trying to achieve the entire non-linear things in between, right? So this is input layer, this is like a hidden layer, and this is a output layer. So entire graph itself is a non-linear. So it's a representation of a non-linear kind of a unit, I would say. So here, so like someone has asked me that whether we are supposed to pass all the input to all the activations or all the hidden units. So yes, we are supposed to pass all the input to everyone. Now in a later stage, it will try to activate, or it will try to deactivate something based on the weight change. Like I said over here, like I have given you example over here, employee ID, right? Employee ID is not having any kind of relationship with height. So if you will keep on passing the data, so it will be able to find out that no, M3 is not having any kind of a significance. right? Means whatever weight that you are trying to consider over here, right? It's not having any kind of a significance. It will start reducing it, right? And ultimately it will be equal to 0. I'll try to show you even with the visual effect, right? Even with the visual effect, I will try to show you a similar kind of a things, right? Just wait for some time and you will be able to see those things for sure. Yeah. So this is what happens in general. So now we have learned about like how we are going to pass our input overview wise, right? So how to pass a different input. What happens when you are going to pass an input? So you try to multiply with respect to like a weight, right? And weight is nothing but it's a random unit that we try to take. Now, so it try to send all of those data into an activation function. So activation function has been used for the normalization as well as to achieve the non-linearity. So activation function itself is a non-linear function which I'm trying to consider. There are many different kind of activation function that we are going to learn, and even we are going to learn a pros and cons of a activation function. A sigmoid activation functions that we have used, it's one of the popular activation function, but again there is some drawback that we are going to find out with respect to that sigmoid activation function that I have used over here, right? So okay, so hidden unit. So again, hidden unit will try to give me some output. We will try to multiply again with the weight over here and here, and then I will be able to finally get an output which is nothing but y hat, and then like see the differences, calculate the loss, and then optimize it. Optimization means nothing but find out a new weight starting from this layer to this layer in a backward direction, which is called as a backward propagation. So overall, this things happens inside the neural network. Now, to understand or to create a better architecture, or to understand or to create a better neural network, what and all things you should know in a very first place, right? So you should know some of the libraries. So now let's come coming to the things that you should know to do this kind of operations, or to train your data with respect to some neural network. So the first thing, right, the very first thing that you should know is a library. So by using which library I will be able to create this neural network, because if you will start writing a Python code for this kind of a graph, you will go mad for sure. So we have a TensorFlow implementation as well, a core TensorFlow implementation, which people don't use on an industry level. So people are generally using, or even we generally try to use a Keras API or PyTorch API directly, right, to create any kind of a neural network. But in your syllabus, we have given you a core implementation in a TensorFlow, a raw implementation in a TensorFlow as well. If you just look into those code, you will literally go mad. And same code, we can write it just within 2 to 3 lines. Same code, right? That we have implemented in 150 or 200 lines, basically, right? Like a work-wise, it is going to give you, or it is going to do the same thing. So first thing that you should know over here is what? A library by which you will be able to create any kind of a architecture. You will be able to decide that how many neurons will be there on an input layer. You will be able to decide that how many neurons will be there into a hidden layer, how many hidden layers will be having. In one hidden layer, what kind of activation functions you are going to use, right? Like I said, so in one layer of a hidden layer, let's suppose if I'm talking about this one, you are supposed to take a same activation functions. And suppose if we have some other hidden unit, right? So suppose if I have some other hidden layer, so I can take some other activation functions over here. So basically you should know a library by which you will be able to design all those things. There are many more libraries which is available and which is possible, right? There are many more libraries which is available and which is possible. One of the popular libraries, two popular libraries that we have over here is TensorFlow and a PyTorch. Again, in TensorFlow, so there is a variance that you will be able to find out. So TensorFlow, TF, and majorly you will be able to find out Torch or PyTorch. Generally, it's called as a Torch, PyTorch. So again, inside the TensorFlow, so you will be able to find out variance 1.x and like a 2.x. You will be able to find out. Now, so again, it's just a library. It just provides you the functions. That's it. Functions to create this kind of a graph. So fine. Again, PyTorch does the same thing. PyTorch does the same thing over here. Again, there are different variants of the PyTorch which is available. Now, so on top of that, so we are going to use a high level API called as Keras. So Keras is a high level API which will make your life very easy. If you are trying to talk about TensorFlow 2.x, you're not supposed to even worry about that because everything is available just as a Keras library in TensorFlow 2.x. 2.x is like a beautiful release, you can say. So TensorFlow and PyTorch, which is available. Again, TFJS is also available. TFJS is nothing but so TensorFlow JavaScript. Suppose if I don't want to write a code into a Python or into a core Java or maybe in some other languages, maybe I can try to use, or suppose if I have to do a computation on a client side. In a later stage, you will be able to see the advantages and disadvantages of both, I would say. So now depends upon the different like scenarios. So we try to use sometime in our product. So we are using TensorFlow JS as well and TensorFlow as well. One to everything. So it depends upon like release versions and the product that we have created. So again, PyTorch. So nowadays PyTorch is getting lots and lots of popularity. TensorFlow is a library provided by a Google basically. So it's been owned by Google. So TensorFlow library was an internal library like for the Google. So Google people have created over there and they have been using it for the internal purposes, right? So in a later stage, they have made these things as an open source. So now it's available as an open source. You're not supposed to pay. You will be able to use it. Now, PyTorch. So PyTorch is a library which has been developed by a Facebook. And PyTorch used to claim some kind of a computational advantages over to TensorFlow. So PyTorch is from Facebook, I would say. Yeah, PyTorch is been from a Facebook, and initially this PyTorch was been used for the research purposes. But in last one and a half year, I can say that there are a beautiful model and architecture people have released with respect to a PyTorch, and nowadays PyTorch is getting a huge popularity. And in a current situation, so it depends upon my use cases or depends upon a problem that I'm trying to solve into a deep learning, machine learning, computer vision, NLP, reinforcement learning. So we sometimes chooses sometimes we try to choose like a PyTorch, sometimes we try to go ahead with the TensorFlow. So as a data scientist, you should know both, and both are almost same. So if you're able to learn one, you will be able to learn others as well. In our class, we have included TensorFlow and we have included PyTorch as well. TensorFlow JS I have not included. When we will try to do some project into a computer vision, at that point of a time, I'm going to show you one or two direct project into a TensorFlow JS. What I feel is like you should know about that aspects as well. Apart from that, so there is another library provider like Cafe is there, Thenos is there, DL4J is there, right? Like ONGNX is there, and there are many other providers of the there are many more library providers is there, right? So yes, depends upon the need, so people are using it, but these are the two most popular library you will be able to find out at any point of time for creating this graph. So yes, the first requirement is to know a library if you have to create your own neural network. Second thing, right? That's the first thing that you should know. A second thing that you should know over here is activation function. So there are a list of many activation functions that we are going to discuss and we are going to talk about. Not only one you should know. You should know almost every activation function, and it's not at all a big deal. Activation function are a very simple function, right? And whether I'm talking about sigmoid or hypertangent or ReLU or leaky ReLU, and every time you will be able to find out some advantages into some activation function, some disadvantages into some other activation function. Generally, people ask me a question that which activation function I should use. There is no good or there is no bad activation function you will be able to find out. It's a subjective one. What kind of a issue, what kind of a data set I'm trying to work, I'm trying to work on. So depends upon that. So I generally we try to pick and choose activation function, and that you will learn with experiments, with a projects, with applications. Basically, yeah. So activation function is one thing that you should know. Then a third thing that you are supposed to know about is a loss function. Loss function or cost function or error function. There is a minor definition wise, there is a minor differences you will be able to find out in between. So whenever I'll talk about this loss, cost and error, so I will try to clarify differences. It's just like a minor differences in terms of words. Yeah, so you should know about that. Then fourth thing that you are supposed to know about is a optimizer. So which will try to take input from the loss, and then it will try to calculate a new weights. So new weights is been calculated by an optimizer. So I was talking about new weight is equal to old weight minus eta into dE by dW. So this factor will be derived, or this factor will be discovered by a optimizer, and there are a different kind of optimizer which is available. So based on loss, like we will try to start from like a batch gradient descent. First of all, we will try to understand what is a gradient descent. Then we will try to visualize it. Then we will try to find out batch gradient descent, a stochastic gradient descent, mini batch gradient descent. And then inside that, so we will try to explore like a Newton's equation. We will try to explore ADA grade, ADA delta, or like Adam optimizer. So these are like 10 optimizers we are going to discuss, 8 to 10 optimizers. Again, 8 to 10 loss function, and almost close to 10 to 11 or 12 activation functions we are going to discuss. We are going to talk about back to back in our class. Now, if you know this much, right? 1, 2, 3, 4 number point, right? If you have an idea about this particular one, you will be able to create, or you will be able to understand any kind of a neural network code for sure, which has not been written by you, which is maybe written by someone else, but you will be able to understand the entire architecture. You will be able to do a calculation as well. Manually, you will be able to do all the calculation. That is possible, like we have done, right? So we know what is the input, and then we know what is the random weights we were having, and then we are able to calculate the output of one hidden new rate. In a similar way, we can calculate the entire network itself, right? If you want. And again, in a backward propagation, right? In a backward propagation, even manually, you will be able to calculate dE by dW. That is also not a big deal, right? Then you can say that, okay, fine. So I understand a neural network in a forward way as well as in a backward direction. Both of these parts are important, and these 4 points covers both of this part, forward propagation and a backward propagation. So unless and until you are not good with this one, so you are not supposed to jump into any specific neural network architecture like a CNN or RNN or LSTM or GRU or LXNet or VGG or ResNet or GoogleNet or DarkNet, InceptionNet, BERT, Elmo, GPT-1, GPT-2, transformers, encoder, decoder, auto-encoder, auto-decoder. So all of these things are nothing but it's a neural network designed for a specific task. So you should not even get into these things unless and until you are not clear with this 4 point. As simple as that. So that should be your priority to learn in terms of, first of all, like create your, this is a base. Now, so many people I have seen that they try to understand and they try to copy and paste a GitHub code, and they try to like create a CNN network for dogcat classification. That is also available in your like dashboard. But that is not an approach. That is not a good approach. If I'll ask them a question that, okay, fine, so try to explain me how kernel is being created, how weight of the kernel is being trained, right? And if I'll just try to ask them a question that, okay, fine, so what is our meaning of a max pooling, mean pooling, or average pooling? What is the meaning of actual meaning of padding? So why we are trying to use a padding, right? What is the meaning of a batch normalization? What is the meaning of a LRN, local response normalization? They will fail. And the reason is very simple over here. Generally, I used to advise these things in my like initial classes. So I think we are in our initial classes. So they generally fail, right? To explain all of those things. These things you are going to like people are going to ask you these kind of things in an interview for sure, right? So it will be very much difficult for you to understand those things unless and until you are not clear with this overview. That's the reason. So in my class, I used to spend a lot of time, first of all, in this one, so that whenever we'll try to get into that level, right, it will be not a big deal at all for you, kind of thing. Yeah. So just try to focus, first of all, to create a base, right? And based on this, I can assure you that you will be able to understand any kind of a code at any point of a time. You will be able to understand going forward almost every kind of architecture for sure. Yeah. So different kind of architecture. Again, many new concepts will come in between, but still this is the base. This things is not going anywhere. Whatever architecture you are going to see in every architecture, whether it's a CNN based, whether it's RNN based, whether it's attention based, whether it's a transformer based architecture, you will be able to see activation function, you will be able to see loss function, you will be able to see optimizer. You are supposed to use either a TensorFlow or a PyTorch, and then you will have to create the entire things, entire network, entire graph. right? So these things are not going anywhere. You can't even give me an exception where you're not going to use it in any of the neural network. So my advice to you will be to get acquainted with all of these things. Okay. Now, so from our next class onwards, so first of all, we will try to understand a derivation. So that will be an agenda on a Saturday's class. So I will, so as of now, I have shown you that, okay, so there is a backward propagation which happens. There is a backward propagation which happens. True. Now, in backward propagation, it tried to update a weight. So it tried to find out a new value of weights. True. By using this equation, it tried to find out a new value of weight. That is also true, right? So I think we are aware about W old. True. Now we are, I think, aware about learning rate, right? So just try to try to smoothen your like a learning curve. We are not aware about this one. This is our main thing which happens into our backward propagation, and we will try to derive these things one by one. So layer by layer, and many new concepts you will be able to get over here. You will be able to see like a vanishing gradient problem. You will be able to see that how my next weight is dependent upon like my activation functions or my previous weights, and many more things you will be able to explore. And you at that point of a time, your entire backward propagation will be very much clear. I'm assuming that this time your forward propagation is clear, right? If I'll ask you to like take one data and then do all the calculation, you will be able to do that. If I will give you a random weights over here, you will be able to calculate like an output. But yes, in a backward propagation, so unless and until you are not aware about this d by dw factor, right? Again, we will end up introducing a bias as well. I'll talk about that. What is the meaning of bias in a later stage? So you are supposed to know this calculation, and yes, this is what we are going to derive, because this is the actual learning. This is where we say that it is going to learn something, and we will try to talk about a gradient descent and local minima and all those things. Okay, now so let's try to visualize something first of all. So I think we had enough of stories, right? So let's try to like visualize. But yes, don't try to jump first of all. Like generally I have seen that people used to jump a lot, and in this way they will end up doing just a copy paste from GitHub code. Okay, so find tensor board playground. Okay, now let's try to visualize whatever things that we have discussed so far, so forth, right? So here Google has created this particular like a tensor board playground for you, so where you will be able to like for a learning purposes basically. So for a learning purposes, so you will be able to like get some kind of a very clear understanding. Okay, now here just try to understand this entire board. In this particular board, so you will be able to find out, let me select like activation function as a sigmoid. Yeah, so in this board you will be able to find out, and you will be able to understand that we are trying to give some data. As you can see, this is the data. Data means nothing but some 2D data I'm trying to give, right? Which we when I say this data, it simply means that I have some dots, right? So over here some orange dot I have, some blue dot I have, and you are able to see some kind of a pattern into a data set. Again, all the data I can plot, every data I can try to plot. If I have a 2D data, I can plot it. If I have a 3D data, I can plot it. Okay, so this is the data that they are trying to give. Again, they have given you 4 such kind of a data, 4 different data set. So every data set is having a different kind of a pattern, as you can see. So you can try to select this data, you can try to select this data, you can try to select this data. So every data set is having a pattern. So 4 kind of a different data set they have given to you, right? Now I'll try to experiment with one. So as you can see that we have what? So we have 2 different values over here, right? So x1 and x2, let's suppose we are trying to take, right? Now x1 is responsible. So x1 is trying to like take input, and x2 is also trying to take the input, as you can see. So both is trying to like take input, right? So input means nothing but so whatever data value that is having, so it will try to take, as simple as that. Now you will be able to find out that we have a hidden unit. This is the input unit, right? And we have a hidden unit over here in this particular place. We have a hidden unit, and here from like we have created 4 neurons into a hidden unit, and here you will be able to find out that all these inputs are deactivated. As you can see, these are deactivated. I can activate it. I can just click and activate it. So here input is going inside this one, from this one, and from this one it is going inside this one, right? So from every input, so your input is getting inside a hidden unit, as you can see, right? Very clearly, you will be able to see that. Now, if I'll try to hold my mouse, right? See, if I'll try to hold my mouse on any things over here, so on every string, so you will be able to find out what you will be able to find out weight. As of now, it's a random weight which people have, which it will try to take by default. Now, at any point of a time, if I wanted to increase a number of neurons into my hidden unit, yes, I will be able to increase it. At any point of a time, if I wanted to create a multiple hidden unit, yes, I will be able to create it, as you can see. So as of now, I have 1, 2, 3. So I have in total 3 hidden units that you will be able to find out, and this is like just an output layer which I'm able to get. Okay, so here you will be able to find out that by default it is trying to take some of the random weights. It's a random weights, right? And here in our output you will be able to find out that this output is basically, it's a classification problem, right? As I have selected over here, it's a classification problem, as you can see in this particular place. Now here you will be able to find out that, so what is the task that I have to achieve? So I have to label this blue dot into blue set, and I have to label this orange one into a orange set, right? So this is the task which we have to perform. This is the task which this neurons have to perform. In this way, you can say that, okay, fine. So my network is able to understand blue pattern, and my network is able to understand the orange dots, right? If it is able to understand orange dots and a blue dot, it is supposed to like just like create some kind of a reason in between, right? So as you can see that I can have a multiple hidden units, right? There is no hard and fast rule that you are supposed to take a same number of neurons in all the hidden units. As you can see, I have taken like a 6 neurons, 5 neurons over here, 4 neuron over here. I can take any number of neurons. It's an experimental things. It's a hypermeter, but it doesn't mean that you can take 500 and 1000. You will learn that how you are supposed to like take a number of the hidden units, and what is the optimal values of the hidden units that you are supposed to consider. So you will be able to learn that. Now finally you will be able to get an output. Here you can see that there is a loss which it is trying to showcase. There is a training loss and there is a testing loss that you will be able to find out. So at the time of training, so it will try to like test all of those like things, means it will try to give input, and then it will be able to get some kind of output, and then it will try to compare. So as you can see that training and test loss is too high as of now. It's almost like a 50% that you are able to get. What I have to do, what is our objective? Our objective is to decrease the loss. So when I'm trying to pass a data inside this one, so our objective is to decrease the loss, right? Now, so it's completely fine. So this architecture is completely fine. Now here you will be able to see an epoch. Epoch is nothing but the number of times you are going to send the entire data set. So once I will start this learning, once I'll click on this button, so it will start like increasing itself. Means that many times it is trying to send the data. Again, there are many more things which will come in between, like a epoch, batch size, step size, many things comes in between. So we'll talk about that again in a future classes. Now here we have a learning rate, right? So I think I was talking about learning rate, right? So here you will be able to find out that it has given you an option to take a learning rate in between 10 to 0.401, right? So you can try to take a learning rate, and you will be able to see like you will be able to see some advantages and disadvantages for sure. You will be able to visualize it actually in some time. Now here you can say that we are using activation functions, right? So yes, we can use any kind of activation function over here. There is something called as a regularization. So L1 and L2, RISD and lasso. So we will try to talk about that regularization factors. As of now, as I'm not aware about regulation, so I'll just try to keep it as a none. When I'll talk about these things into a class, so then you can try to use it. Regularization rate is equal to 0. Problem type, so what kind of a problem you are trying to solve? Classification problem or regression problem? In classification problem, it will give you classes 0, 1 kind of a thing. In case of a regression problem, so you will look for the values, right? So a final values, like if I'm talking about a height and weight kind of a situation, so there I was trying to predict the height, so that comes under regression, where you're trying to get the numerical values, final numerical values. But if I'll try to talk about like a rating, or like a Swiggy Zomato rating, or maybe if you go and give a rate to someone else, or like a 0, 1, yes, no kind of a thing, these are the classes, which again like you will learn gradually, classification and a regression one. Now here in this case, in this area, so there is something called as a batch size. I was talking about batch size. right? That we are going to discuss batch size, step size going forward. Noise is nothing but, so if we have to introduce some kind of a like a random data, random values from our side, we do that. We try to introduce a noise sometime from our side, some unwanted data from our side, so that our model will try to modify, or our model will be able to modify the weights accordingly. Okay, so again, noises we can use, we can't use. So as of now, I have just given as a 0. Ratio of training to test data 50%. So I can try to increase that one, right? So I can try to decrease that one. So as you can see, so this will change, right? So train test ratio. So I can try to increase and decrease. I can try to increase or decrease noises. So as you can see, noise means what? So as you can see, noise means, so I'm trying to give some of the dots, some of the noise means I'm trying to reduce some of the noises over here. So you can see that my orange dots is coming in between my blue dots, and my blue dots is coming in between the orange dot. That is called as the impurity or noises. If I'm going to like give noise equal to 0, so in that case, I'm not introducing any kind of a impurity over here. So you will be able to visualize that particular factors in a easiest possible way, as you can see. So it's a huge noise that I have end up introducing. Means 50, like a 50 random data, or 50, I would say, a data set which I have included, which is having no significance with respect to our data set. Okay, batch size. So again, batch size means how many data set it is going to take. So I can try to give a huge batch, but generally we don't do that. I'll talk about batch sizes. What is the optimal batch sizes you are supposed to take? As of now, I have deactivated these factors, right? I have deactivated this entire factor. So test data, if you are going to do, so this is the so test data. So these are the test data. So I was trying to find out test loss and training loss, right? So as of now, it is just trying to show you training data. If you wanted to see test data as well, so this is the test data. Based on that, it is going to calculate the testing loss. Because whenever you try to build some network, so you try to divide your data set into training and testing. Same thing you will do for sure. Now discrete output. So yes, again, like you will be able to find out that some discrete value, some discrete output is going to give it to you, right? Now let's start this network, right? And focus on this one. Focus on this one. As of now, it's showing you 0 point of almost 50%, close to 50%, right? Just focus on this one and just remember some of the weight, right? As of now, I have taken a random weights. As you can see, system itself has taken a random weights, right? And here, so everywhere, like you will be able to find out like activation functions, right? Everywhere we have taken like a sigmoid activation function. Sigmoid, this is something that we were talking about. Now, what I will do is, so I will try to start. As you can see, the loss, see the losses, it has started decreasing. So the initial value was different, and you can just observe this epoch. And now just check your weights. So now weight is minus 0.49 for this one, right? So it will change after some time for sure. If I have to converge faster, maybe I can try to pick and choose like a high learning rate, 37. It will change. Just wait for some time. I have taken like too many hidden units. 37. Yeah. Now, if I have to convert these things faster, so in that case, what I will do is, so let me convert these things in a fastest possible way, right? So I'll try to like use learning rate is equal to 1 if I'm looking for a convergence. And let me remove some of the hidden layers. Okay. Now, let's see. Now, as you can see, right? And you can just look into this particular this screen. Just look into this screen, right? It is trying to take a save, as you can see, right? So this is what happens, and you are able to see that these weights had changed immediately. Now, how I am able to do that? Because I know what will happen and when it will try to train itself faster and when it will try to train slower. So based on that, based on my experience, so I have just opted for a learning rate and I have opted for other values, right? Because I know that in which conditions it is going to converge faster. And you can see that training loss and test loss is equal to 0, right? You can see this graph. It's coming to 0, and you can just look into this picture over here. So yes, it is able to take a save, right? And it's a perfect save that it's able to take. Still, my things are running, but yeah, so I'm able to get training and test loss is equal to this one, right? And as you can see, this is the flow that you will be able to get, right? This is the flow that you will be able to get. Now, so this is nothing but if you try to hover your mouse, so you will be able to find out that some weights, right? Now someone was asking me that, so we are going to give all the weights. Yes, we are going to give all the weights if there is no relation. As you can see, just look into the string closely, just look carefully over here. It's a white one, right? This is so like a weight value, or you can see that the string or the data which is going to pass from one end to another end, right? So this data set is not same, right? This string is not same, or weight is not same. So initially it has taken almost a similar kind of a weight, but here you will be able to find out that after training, so it has changed and it has deactivated some of the weights, or it has deactivated some of the relationship by itself, right? So some of the relationship is been deactivated in some of the layers, right? Some of the, see this one that is going to contribute over there. So yes, it's been decreased, some of them are increased, right? So this is something that it tried to do by itself. Now it could possible that I can try to take learning rate is equal to 10. Okay, so like I'll just have to refresh it, right? So as you can see, as of now, like weight is equal to this much, so almost all the weights are same. Maybe I can try to remove this hidden unit as well. So this is the only unit which I'm going to consider, right? And learning rate is equal to 3 if I'm going to consider. Now you can see the magic. Yeah, so my weights are different every time. So my weights are changing, so some of them is getting activated, some of them are getting deactivated, and in a easiest possible way, very slow, easily it is able to converge. It could possible that I can change the data, right? So let me do these things with this data. This in this data set, so it is supposed to classify a different pattern basically, right? So as you can see, like it is able to do that. It is struggling, I would say. So it is able to perform better in this area of the data with this data set, but in this area of the data set, still it is struggling a lot, and that's the reason. So you can find out that we still have a huge loss in this particular case, right? So and again, so here basically like whatever parameter which I have taken, so these parameters are not a suitable parameter. I have taken learning rate is equal to 3. Maybe now I can try to use 0.3, and then I can try to train. So I can try to train by using 0.3, and now you can see I have changed the I have changed basically what I have changed basically a learning rate. I was trying to tell you, right? So there is something called as a slow learner, there is something called as a fast learner, right? So if I'm going to give a huge learning rate, it will try to converge very faster, and in this convergence, the way you try to learn, right? So generally like what happens is, whenever I'll give you column statement, you will try to search for the GitHub repository, and then from there you will start doing a copy and paste operation, and in this way, so you will not be able to learn anything. Although you will be able to temporarily implement something, but yes, you will not be able to learn anything, right? Because you many of us always looks for a quick learning. So in quick learning, last time I have taken learning rate is equal to 3, and it was not able to classify blue in blue and like a orange in orange. But this time I have not changed any other parameter, just learning rate I have changed, right? Now it's able to converge in a proper manner. Even loss it is able to decrease, right? And it is able to change the weights as well. So this is what happens in case of a neural network. And whatever factors that you are able to see in your screen, you are supposed to know about every factors. Doesn't matter which neural network architecture you are going to explore, which research paper you are going to read out, right? But unless and until these things are not clear, it's not possible. So fine. So here is here is everything for you. So if you wanted to go through this one, so you can just go through this one. The name of this entire screen is called as a tensor board playground. So if you will go to Google and try to search by using a tensor board playground, you will be able to get that. And here is a link for you. So in your chat box, so I'm just going to give you a link, so you can just try to use this link. It's already available in your chat box, or else just go to Google and try to search by tensor board playground, and you will be able to get it in a easiest possible way. Okay, so fine. We should take more learning rate greater than 20. Yes, you can do that. So here, like in this tensor board playground, they have not given all the activation function, they have not given all the regulation technique, they have given some basic one, right? You can try to use in a real time. Whenever you will create your own network, you will write your own code. So at that point of a time, you can try to like take learning rate anything. But again, don't take 20 at all, right? Your entire thing will go for the toss, I would say. So entire things will go for toss. You can try to test it here itself, right? So don't try to take see, learning rate is equal to 10, right? It is not able to learn anything. It is not able to classify anything, right? Everything it is able to understand as a orange. See, whatever data you are going to pass, but it's trying to understand everything as a orange. So don't try to like take a huge learning rate. Always we try to take a learning rate in between like a 0.01, 0.03 or something like that. You always try to take. You will learn all those things with experiment. I think it's too early for you to know that. Learning rate is as minimum as possible. No, again, that concept is completely wrong. So if I'm going to take a very like a less learning rate, right? So again, in that case, so it will take time and your system will go mad. See, so almost like a 100, more than 150 times it has passed the data, but still it is not able to converge. So that's the reason I told you it's a hypermeter. It's an experimental thing. So we try to experiment it with respect to a data. Maybe with other data, same learning rate that I have taken is going to work for me. But with this data, no, right? So it's an experimental thing. And yeah, you guys will be able to understand. Can we use different learning rate in our neural network? I think I have given all you the answer, Abhishek, right? So try to like focus on a class when I have already told you more than 10 times. Okay, so fine, guys. So I think like what is the time now? Okay, so I had a plan to talk about one of my slides. Yeah, this slide actually. So again, created by one of my students. So that whatever we have discussed, so we will be able to conclude each and everything. So his name is Sunny. So he has created this one. So let's try to recap and let's try to revise everything. So as we have seen that, okay, just this is the same thing. I'm not going to discuss anything new over here, just the same thing in terms of beautiful PPT, right? Or whatever diagram which I have drawn by my hand. So there will be an input. It will get inside, I would say, like a neural network, and summation of input will go inside the neural network, and it will go inside the activation function ACT, and then it is going to give you the output. Now adding to the same slide, so now, so output you will be able to get, right? So yeah, as you can see, so summation is like this is nothing but a plus b plus c, a plus b plus c with respect to weight we are trying to give as an input, right? This is a sigmoid function. I think I was trying to draw. So sigmoid function for any kind of a value in between minus infinity to plus infinity, it is going to give you output, means y value in between 0 to 1 at any point of a time. Now, so simple input and output we are able to get now here. So input layer, or you can say like a buffer layer, right? So generally we used to say these things as an input layer, which will try to take the data. And now, so you can say that we have an output layer. So in an output layer, we can have one neurons, we can have a multiple neurons. It depends upon the use cases, depends upon the kind of a problem that I'm trying to solve with respect to a data set. Now, so yes, in case of a classification, so there can be a multiple classes, and in case of a regression, so maybe I can look for only one values, right? So depends upon that, we try to create a neural network, and these are the example which has been given to you. Now here, you will be able to find out that we are trying to give an input. I think this is what I have explained you, that there is an input that we are trying to give, and there will be a weight, right? So W11, so this relation, this weight, and 2, 1, so 2 and 1, so this weight that we have. So final input which will get inside over here, let's suppose our Z1 is nothing but, so input weight, so summation of that, input weight, summation of that. I think this is some same thing we have discussed, right? So just for like just to recall a same thing. Now, so what you will try to do is, so you are going to pass this Z1, you're going to pass this Z1 into where? Into an activation function, and then you will be able to get an output. If it is just like a, you just have like a hidden units over here, so yeah, after that, if you're looking for just an output, if you don't have like a further hidden units, otherwise this output will be the input for the next layer. Okay, now simple. Z1, Z2, I think we all are able to understand it. It's like what is Z1 and what is Z2. So again, it will try to give you some output, right? So calculation wise, if I look into this calculation, so it's a same thing. So whatever we have discussed just now over here, right? So Z1 is equal to W1, I1, W2, I2. So generally in many books, you will be able to find out that they try to represent everything in terms of matrices. Simple. So what they used to do is, suppose I have two inputs, right? Suppose I have two inputs. I have two neurons as an input, and let's suppose I have hidden layers. So this is hidden unit. This is the input unit, I would say. Now, so here, like four different like four weights is required. 1, 2, 3, 4. Right? 4 weight is required. 2 plus 2. 4 weight is required. So yes, we have taken 4 weight over here, right? And then we are going to do a multiplication. So again, Z1 and Z2 we were able to find out what was Z1. Z1 is nothing but, so this input into this weight plus this input into this weight, right? This is Z1. This was Z1, right? So many books you will be able to find out this matrix representation. It's nothing but it's exact same thing that we have discussed, right? So here Z1 is nothing but, I can say this input. So let's suppose I1 into like weight 1 plus this, let's suppose this is I2. So I2 into, let's suppose this is W2. So W2, same calculation we are trying to do over here, nothing else, right? So it's just a matrix product, you will say. So here, if we know that if we have such kind of a matrices, this kind of a two matrices, if we have, and if I'll ask you to do a matrix multiplication, so how matrix multiplication happens? You will try to multiply this with this one, addition and multiplication, and you will try to multiply this again with this one. So if I'll try to perform this matrix multiplication operation, because internally neural network always try to do a matrix multiplication, right? So it's very simple. It's the same thing that we have discussed. No need to get into a complexity of it's not complex at all, I would say. Okay, so here like W1 into I1, W11 into I2, right? And like in this particular place, so W1 into I1 and W2 into I2. So this will give you Z1 we are able to get, and W12 into I1 and W22 into I2. So this is something that I will be able to get as a Z2. And yes, we were able to get a same thing, and then we are trying to send this Z1 and Z2 into where? Into activation function, and then we are able to get two Y values. So if we have two classes, we will be able to get two Y values. If we have only one classes in terms of like, so I will be able to get only one if we are trying to solve some regression problem. So in that case, I will be able to get only one output at any point of a time. Now, so weight I, right, Z, simple, right, Y hat. So this is an overview of a same thing that we were talking about. So yes, this is the same simple equation, right? I think this is the simple equation that I was talking about. So weight into input is equal to Z, and then Z we are trying to pass into activation function, which will give you Y or input for the next one. Now error calculation we have to do, right? So error calculation, how we are going to do error calculation? So predicted value and then actual value, the expected value. So difference between predicted and actual values is equal to error, and there are many ways to calculate the error. So don't think that it's Y minus Y hat. No, it's not like that. So sometimes we try to use a RMSE, sometimes we try to use like a different kind of loss, log loss, and many other things as well, which we'll try to understand. So here we are trying to like find out the error. So we are able to find out the error, and let's suppose like this is a value of a W1, W2 that we are able to get, right? So it will try to back propagate the error. So here manually we are trying to show you that, okay, fine. So like how we are trying to back propagate the error, right? So this is not something which happens actually in actuals. This is just a representation, because in actual it will always try to find out the derivative, and then after finding out the derivative, it is going to give you the error values in general. Okay, so as you can see, like we are like trying to multiply error with weight, and then we are trying to like find out a new weight values, right? So like error at neurons 1, So this is not actual mathematics. This is not the actual calculation. Don't go after that. dE by dW is the actual mathematics, which we will try to discover. It is just a representational one. Okay. So like error we used to calculate in every layer. So dE by dW we try to calculate in every layer, and then we try to adjust a value of the weight. So the new value of W11 will be, you can say this one, again representational value, right? This one, and this one multiplied with error 1, error 2. So we'll be able to calculate the error, and yeah, so we'll try to calculate the error, and that is the ultimate goal. That is the whole idea, to calculate the error at any point of a time. Simple. If we are able to calculate the error, and based on the error, if we are able to change the value of the weight, right, my work is done. As simple as that. Okay, so this is what happens in general. So now I'm assuming that you have a very clear understanding about a basic of neural network, not in depth. So it's completely fine if you don't know about like what is a different kind of activation function, what is a different kind of a loss function, and optimizers, what is a meaning of epoch, what is a meaning of a step size, what is a meaning of a noises, what is a meaning of biases. So it's completely fine if you're not aware about that. I'm just talking about these words because so that from next time onwards this word won't be new for you, right? So yes, now can you guys confirm me that how many of you are able to understand these things? You can write this your answer in terms of percentage. Okay, 100%, 90%, 99.99, 100, 170, 70, 65, 60, 40, 60, 70, 100, 100, 100, 100, 90, 80, 100. Okay, 99.9, 70, fine. 50, 60, 95, 78.99. Got 100% partially. Okay. 80%, 100%, 90, 199% hypothetical value, 200% again hypothetical value. Okay, fine guys, I got the sentiment. So in every classes I used to collect the sentiments so that I can decide like whether I should go slow, whether I should go fast. And don't worry. So it's just your second class, right? Just your second class. So like my intention was not to talk about the entire neural network at this point of a time and all the like things which comes inside the network. My intention was to make you understand that when we say learning is happening, it is trying to understand some relationship between the data. So from the 10,000 feet over, from 10,000 feet, so you should know how it will happen. Then we will try to observe from a 1 feet, where we will try to learn everything, every component of the neural network, and manually we'll be able to calculate. Although it is not required, although like you're not supposed to like know all those manual calculation, you're not going to do it even, but at least for first time and at least one time you are supposed to do it by yourself, so that things will not be a black box for you. Neural network will not be a black box for you. You will be able to understand and you will be able to visualize the entire flow of the data in forward direction as well as in a backward direction, both. Because we all know that in a backward direction learning happens, and we all know that meaning of learning is nothing but changing our weights, and how we are changing our weights based on the laws. Yeah, so I think I have repeated all of those things enough number of times so that you will not be able to forget even a single word out of this, right? How did you calculate e to the power z? You have a calculator, right? You will be able to find out e symbol over there. Just calculate it. So can we use a neural network when dependent variables are absent? Dependent variable are absent means, are you talking about X or are you talking about Y? Thank you, Samit. Training and testing error. We'll talk about that. See, many things like I have clarified, right? So I was just trying to give you a 10,000 feet overview. In a very first day, don't try to like increase your learning rate. Just try to go like with a slow learning rate, and then gradually try to increase your learning rate, right? That will be a better way of learning. So don't try to don't try to know everything in today itself. If you wanted to know, it's completely fine. Recordings, my previous class recordings are already available in your dashboard, where I have taught everything in the same way. Okay. So just try to like maintain your learning rate. PC and EDA is required before this one. I don't know from where you are getting all those questions, right? So you will try to understand. Just wait. Siva, will the weight be equal for the entire record? Any changes only after every record? Will the weights be equal for entire records and change only after? What was that? Let me copy your question. So Siva is asking question that will the weight be equal for the entire record and change only after every epoch? I never said, Siva, that weight is going to be equal. Even visually I have shown you. Then where is the confusion? Why you were not looking into a screen in a TensorBoard playground? And even in the regression problem, can we use a sigmoid? Yes, sigmoid is activation function, which is not related to a regression or classification, which is related to basically like a non-linearization and normalization. So sigmoid is not going to hit you're not supposed to consider activation function is having some relationship with your problem type. Are the weights only decreased, can be increased? I think I have already given you this answer, right? I clearly said that it could be a negative sign, it could be a positive sign of d by dw, and based on that it can increase or decrease. Focus on a class, guys. Focus on a class. I can see like all these things step by step I have clarified, but still you guys used to ask the same question. Test loss is calculated after every epoch in TensorFlow Playground from the for all the okay. Test loss is calculated after every epoch. You can say that it depends actually. So it depends upon my neural network design. So yes, in TensorFlow Playground, so they are trying to calculate it after 10 steps. That's the reason. So you have taken a step size equal to 10. So why we are trying to achieve a non-linearity via the activation function? Because I don't know whether my data set is like having a linear tendency or non-linear tendency. If it is having a linear tendency, it will try to train it, or it will be able to find out. If it is having a non-linear tendency, it will be able to find out. So I'm just giving my option or flexibility to my network. That's it. Can we have our different activation functions at every layer? Go through this recording tomorrow when I'll upload it again. I have already told you 10 times. Just try to take this much of pain to understand. Why do we use a hidden layer? Okay, so why do we use a hidden layer? Because we are supposed to create as many parameters as possible to understand a relations, basically. So because whenever we are introducing a hidden layers, so I can say that I'm trying to introduce a more weights, means more parameter to learn, I would say, or more flexibility I'm trying to give to my network to like learn something new. That is one thing. Second thing is we are trying to use activation functions in our hidden layers, which is responsible for normalization and which is responsible for like achieving or finding out the non-linearity. Otherwise, if you have just taken an input and output, then why do we need like a why do we need a neural network? It will take the input and will give you the output. Simple. Nothing will happen in between. There won't be any kind of a weight. So that's the reason. Data should be linear or non-linear in a neural network. Please clarify. Go through my recording cues once again. Do more hidden layer gives us faster process of process of reducing the loss. It's an experimental one, basically. It's a hypermeter which you will know and which you will learn. Because see, when I was trying to like go through a TensorBoard playground, I know that okay, fine. So like this is how it is going to train very quickly. Because from my experience, I can clearly observe. I can clearly observe the pattern of the data. I can clearly observe all the parameters, and I can set in a single shot itself. I will be able to set, and you will be able to find out that it is going to give you a classification, a better one. But as a newcomer, right? If you will try to do the same thing, you will have to experiment, right? And then you will get to know. So let's try to like do a lots of experiment, create our own neural network, write a code, train with the data. You will get to know. Can output be input to another ANN? Yes, that is possible. We try to do that. Is PyTorch going to teach? Again, don't sleep in a class. If you think that if you will sleep and out of sudden if you'll ask any question, don't expect those kind of things from my side. I always force people to learn in a better way, right? Although I can answer all of your question, that is not an issue. I have already taught these things in your class itself, but still. Do we have similar PyTorch playground? No, there is no similar PyTorch background. Why do you need PyTorch or TensorFlow playground? It's simple. It's just a visualization. So I'm getting Windows DDL error while installing TensorFlow 2. Don't do that. When I'll discuss TensorFlow 2.0, my team will help you out. Or else just try to create a new environment. I think that will be better. Kevin is asking, can the error rate be 0? Won't it be at the overfitted model? So error rate be, yes, see, depends. If I'm just trying to take a very simple data, right, which is having a direct relation, so in that case it will be easier for you to achieve a error rate is equal to 0, right? I can't say that like it will be an overfitted model unless and until I'm not going to give us unless and until I'm just giving a data which is having a similar variances as compared to the training data set, right? So I won't go with a statement that if error rate is equal to 0, so in that case it will always give you overfitted. Yes, it gives overfitted one, right? But at least not with this simple data set. So if your data set is having a huge variances, so again bias variance trade-off, and then it will go for the overfitting. That is true. Many people say that if error rate is equal to 0, all the models are overfitted model. Blindly they used to say that, but I don't agree with the same line. Okay. So let me take some other question as well. Okay, let me unmute couple of you so that you can ask a question directly. So guys, there are like a raise hand option. You will be able to find out. So those who have a question, they can raise their hand, and please try to ask a sensible question in my class. Otherwise, I'm not going to give answer. Simple. Yeah, go ahead. Yeah.
Hello, Sudhanshu. Yeah, actually, why do we need multiple hidden layers? We can have one single layer having multiple neurons.
Can I say that? Yes, just wait. So can I say that I think I'm getting a lot of noise from your side, Nix. So see what happens is, suppose if I'm going to introduce a more number of hidden layers. So can I say that I'm trying to introduce basically, so if let's suppose if I have a multiple hidden layers over here, so multiple hidden layers over here, so I can clearly say that I'm trying to like get a more number of weight over here, right? It simply means that, so I'm trying to give a huge flexibility to my network to learn many weights, right? So I'm trying to increase the learnable parameter, because weights are basically a learnable parameter. So it means if my data set is too complex, so even if we are like, even if we have a too complex data set, so it will be able to understand those relationships. That's a whole idea, and that's a whole reason behind giving a multiple hidden units. If it is just a one hidden unit, then learnable parameter is equal to like depends 3 into 3, so 9 max to max, right? Or like, but here if we are trying to introduce some more hidden layers, it means we are introducing some more weights, and in a backward propagation it will try to train this one as well. There is a advantages you will be able to find out, and there is a disadvantage as well when we are trying to say that we are going to increase a hidden layer. So it's not like always like while increasing this particular, I would say, like a number of layers, so you will end up getting a benefit of this. No. So you will be able to find out that there is a problem called as a vanishing gradient, and there is a problem called as a, whenever you will try to do a back propagation, so it will not try to like update the weights which is available on a first layer if the depth of the network is too high. That you will be able to understand after next class, so after this calculation. So yes, you can try to take any number of hidden layers, that is fine, but it's not always going to be beneficial. And the answer to your question is why we are including a multiple hidden layers, so that we can try to increase a more learnable parameter, so that it will be able to understand more complex data set. Next question, please.
But sir, in single layer, we can have multiple neurons. That includes multiple weights. So that will also help.
That will also help. That is completely fine. But here, so if I'm trying to increase maybe a multiple neurons over here, so I can clearly say that the calculation which I'm going to get out of this one depends upon the previous layer, right? But let's suppose if I'm going to increase some new layer over here, so now this calculation depends upon this one. So can I say that data is going to change? So the data that you have passed from here and the data which you are trying to pass from here to here is having a difference, right? And it will help our network to learn a complex one. So yes, you can try to increase a more number of neurons over here, but this layer of neurons just depends upon this data, just depends upon this layer of data, which is not a very good approach. So if I have to learn a complex data, so always we try to create a multiple layers over here. So these are the experimental, I would say, like experimental things, and it's a subjective things, and it changes with respect to our data. But yeah, that's a whole idea. So instead of giving a more number of neurons, so sometimes we try to create more number of layers, because one layer calculation depends upon the previous one.
So adding more layer mean more adding more dimensions to the.
So adding more layers simply means that giving a more flexibility to the model, because what is how it is finding a relations? Can you please tell me how it is finding a relations? So based on what it is finding a relation?
Through weights, means it is
through weights, right?
Yeah.
So yes, so adding more layers means what? I'm trying to increase, can I say that I'm trying to increase a more learnable parameter, right? Now, so even like you said that, okay, so instead of increasing the number of, I would say, like hidden layers, right? So I can try to increase unit of a neurons. So even in this case, you can claim that, okay, I'm trying to increase the weights, right? I'm trying to increase the weight. You can claim that. But the idea over here is that this layer is trying to get an input from here, this one. Now, so if I'm trying to increase, let's suppose, a number of neurons, so all the calculation which we are going to do over here, let's suppose activation function calculation that we are going to do over here, it just depends upon this layer of data, right? So maybe it has missed some of the relations, right? Because all the calculation is going to happen just based on this input layer or this data. So let's suppose if we are going to add a new layer, so in this case, it will depends upon this data. It depends upon this output as an input to this one. So in this way, it will be able to find out more complex, I would say, relations, right? And that too in a better way. So even in this case, we are increasing the number of weight we are increasing even in this case, but this approach of increasing the number of weight is always better as compared to this one in general, you can say. But in a later stage, I'm going to tell you that no, you are not supposed to increase a hidden unit beyond certain limit, because there is some disadvantages you will be able to get. And that is the same comparison you are going to study in between LXNet, LeNet, and VGG16 and VGG19. So based on that, so people have designed those networks. Yeah, that's idea.
Thanks.
Sir, 0 to 1, hello?
Yeah, go ahead.
Sir, when you mention the output, the weight is from 0 to 1. Even when initially when it starts, it's going to be 0 to 1. But when you say when after the activation function, so still like only after the activation function, it should be to 0 to 1. Sir. That part I didn't understand, sir.
Sorry, which one?
After the sigmoid function, like activation function, only then it gives the point as 0 to 1, or even moving from the initial weight itself is from 0 to 1, sir?
No, how initial weight is going to be 0 to 1? Because what is the input which is getting inside the activation function? Can I say that actual input into weight, right? So yes, summation, multiplicative summation of all the inputs into weight which is going inside sigmoid, right? So it's a property of a sigmoid function that it will give me 0 to 1. Let's suppose if I'll try to use some other function, ReLU function, right? Which try to give me like a maximum for the positive data set and 0 for the negative data set. So again, like those functions is been designed to give me some different kind of output. Sigmoid is a function which just give me values, but yeah, the value which is getting inside the sigmoid. So we have already seen that those values are not at all like in between 0 to 1. You can try to take any values of the weights. Let's suppose weight is equal to 1 to 3 and input is equal to 4, 5, 6. Now you will try to give the input. So can I say that those input will not in between 0 to 1?
Yes, sir. Yes, sir.
Yeah.
So initially in the first phase only, it's going to be a different weight. Only after the activation function happens, it's going to be 0 to 1. Correct, sir?
No, weight is not going to be 0 to 1. You're not like, okay, I think you have missed that part as well. So it is going to give you output. Again, output into weight you are going to multiply. So that output will behave like an input for the next layer.
Okay. Okay.
Right. So the output will be which will behave as an input for the next layer is going to be in between 0 to 1, because that is the output from the sigmoid we are able to get. Does it make sense?
Okay. Yes, sir. Yes, sir. Okay, sir. Okay.
Okay.
Sir. Got it.
Someone is asking questions that can we have a skip connection in ANN? So ResNet has been designed based on the skip connection. Try to study ResNet.
This is regarding continuation to the previous question.
Yeah.
If you are taking input as 1000 and if it is multiplied by some weight and if you pass it through sigmoid function, it will be 0.1, like it's a 0.5. And if it is a regression problem, and how is the value scaled back to the actual value? in the output column.
See what happens over here is, so whenever we are talking about a regression problem, right? So let's suppose I have a very simple unit. Just try to do this experiment, I would say. Okay, so let's suppose from here, this is the activation function, right? So I'm assuming that it's giving me 0.5. Agree?
Yeah.
Now let's suppose here weight is equal to 10, right? This one is giving you 0.4. This one is giving you 0.3 because I have applied the sigmoid activation function, right? So it's giving me 0.5, 0.4, 0.3, and weight is equal to 10, weight is equal to 12, weight is equal to 5, right? So now what is the output that you will be able to get? So 0.5 into 10 plus 0.4 into 12 plus 0.3 into 5. Now, so 10 into 5, so 5. 12 into 4, 4.8 plus like a 0.3 into 5 is equal to 1.5, right?
Okay.
So here in total, yeah. So
weights will be adjusted.
Exactly, right?
Okay.
This is what I was talking about. It's a very simple thing,
I thought
right?
like, I mean, how is the output visible? Like, okay, now I'm
got it, right?
Yeah.
This is what happens in case of a regression. It's simple weight, right? So your data is not going to change, just it's a weight.
Okay, got it. And regarding that first question, like, let's say if there are 100 records in a table, like for every record, the weights will get adjusted.
No, that is not a thing actually. That's the reason. So we are going to talk about SGD, BGD, and mini batch. Yeah.
Okay.
So then you will be able to get a clear answer that okay. So how how much data it tried to take actually. So I think I have not discussed SGD, BGD, and mini batch. I'll try to discuss in my upcoming classes.
Okay. Like
Sir, I wanted to ask.
If you wanted to go in fast track, videos are available. Yes.
Yeah. Sir, I wanted to ask, like, can this solve all the types of problems? Like,
yes, it can solve all now everything means everything. Whatever you solve in machine learning, it can solve time series, everything is solvable into a neural network. Everything.
Okay, and so another thing I want to ask, like, activation function is created for every layer.
Every layer means hidden layer actually, not input, not
every
output.
hidden layer.
Hidden layer, yes. Input will be a first layer, then output will be a last layer. In between, whatever layer you have, in every layer, we try to give a activation function. Yes.
So it has been said that data processing is not required in this deep learning neural network. So is it so?
No, it's not like that. It's required. You will get to know.
Okay.
Yeah.
Can every layer like have different activation function?
How many times I have to give you this answer? Good. So fine, guys. I think I'm done with this class. Yeah. So guys, just try to practice as much as possible, right? And go through our lectures, go through our videos as much as possible. Don't try to jump, first of all. Like I told you, so human neural network is almost similar to this artificial network is almost similar to a human network, right? Neural network. So the way we used to train like artificial networks, in the similar way, you are supposed to train yourself. Your learning rate should be a steady one. Then only you will be able to get a better result and better output. If you will start jumping, which everyone does, I completely agree with that. Everyone think that, okay, fine, so let's try to complete these things. Let's try to learn these things in a 1 day, 2 day, right? And in this way, you will end up jeopardizing everything, right? From my experience, I'm telling you, and from the very first class, I keep on advising my people, for sure. It's my job, I can say. So don't try to jump. Try to grow in a steady pace, right? Maintain your learning rate. In a later stage, you will be able to increase your learning rate, right? If you'll just go slow and just revise, and nothing much you have to study as of now. Just try to spend half an hour just for the revision, right? I think half an hour is more than enough to revise each and everything that we have discussed, right? And so that you will we can start avoiding your repeated unnecessary questions, for sure. Yeah. And just try to think, right? Just try to think, build a thought, try to visualize things, right? Nothing is a black box. Everything you can prove mathematically, everything. And everything is a mathematics, and code is nothing. Simple. Coding means it's like a code is nothing, I would say. And we don't consider coding as a part of our job even sometime, right? So yes, coding, with the help of code, you will be able to deliver the application, you will be able to build the application. But if you understand a concept, if you understand a mathematics, you yourself will find out that no, coding is not a big deal. It's very easy to do a code, but if you are not able to understand these things, right, no one can help you out. You will end up doing just a copy paste for your entire life. So it's your life. You have to pick and choose. You have to decide that what kind of a data scientist you wanted to become. A kind of a copy and paste kind of a data scientist, or an actual one who understands things, who can visualize things, who can connect things logically, right? So always try to build your logic. Always try to seize everything in terms of logic. Nothing you are supposed to by heart. So you're not supposed to memorize anything. Everything is very logical, right? Just you have to connect. So connect all the strings one after another. You have to understand the flow of the data. Simple. In a network. And this is how it happens. Whether it's a machine learning, whether it's a deep learning, everything is the same story. So always try to focus on this part, this visualization part, and understanding or connecting the strings one after another. When you will go for the interview, doesn't matter what kind of a question person will ask, you will be able to answer everything. The way you are asking me a question, right? I used to answer all those things. In a similar way, you will be able to answer. It's not that difficult. The only thing is, if your concept is clear in bits and pieces, and logically, if you are able to connect everything, if you are able to think about it logically, right? That is my advice to everyone. And yes, I will try to take all of your questions, but first of all, go through lectures and go through whatever things we are trying to discuss. Second camera is better. Yeah, so second camera is better. Okay, so fine guys, I think you have enjoyed this class, right? And see you again in next class. Work hard. And whatever doubt you have, so you can ask all of your doubt in our next classes, which is going to happen on Thursday, which is like a doubt initiation. Those who have a doubt, so they can raise all those concerns, they can raise all those doubts, and I'll try to clarify in doubt initiation for sure. But before that, make sure, in a doubt doesn't mean that you can just ask anything. So make sure that you go through it, right? You're trying to study for yourself, not for us. So if you are going to work hard, if you are going to spend time, it is going to help you out, not me. So simple, just try to work hard and then try to ask a logical things. I'll explain, not an issue. I'll explain, I will be happy to explain a complex things 10 times. I don't have any kind of issue. And that too, all the 10 times, I will try to explain same thing by using a different scenario, right? This is what I do in my classes. So fine guys, thank you so much, and see you again. And yes, enjoy your weekend, whatever is left.